before you watch the video, subscribe it, click on the bell icon for more notifications. Hi everybody, welcome to AGAA-MATH. This is Rakesh. Today we are going to learn about the proof for the relation between zeros and coefficients of a polynomial. First of all, I'll take linear polynomial and we see the relation between the zero and coefficient of a linear polynomial. Right? So here we have to know the standard form of a linear polynomial. Okay, how do we write the standard form of a linear polynomial? If you take, we all know or also call the general form of a linear polynomial or the standard form of a linear polynomial, right? So whenever we write the standard form or the general form of a linear polynomial is, that is ax plus b, right? So ax plus b, where a is not equals to 0, where a is not equals to 0. We know that if a becomes 0, so there will be no variable here, so it doesn't become a linear polynomial, right? So if a is not equals to 0, then that becomes a linear polynomial. Okay, now so how do we find the zero of this and making a relation between zeros and coefficients? So here p of x, let me take that p of x is equals to ax plus b, right? And for this linear polynomial, let what we do is, let's take that k is a 0 of this given polynomial. K is a 0 of ax plus b. It means in the place of variable x, if you substitute k, that should be equals to 0, right? So that what I do is a of k plus b equals to 0. Then ak is nothing that minus b, where k is equals to minus b by a. So as k is nothing but minus b by a. So this is minus b by a is a value, like minus b by a is 0 of this ax plus b. When I would like to make the relation with coefficient, now 0 is what? Minus b by a. When I would like to make the relation with coefficient, how do we write? It's very simple, right? So minus b by a. If I observe this polynomial ax plus b, b is the constant, right? So minus constant term by, and what is a? Coefficient of x, right? So a is coefficient of x is a coefficient of x. So minus b by a is a 0 and it is related with now minus constant by coefficient of x. So this is about the linear polynomial. Then let us see how do we make the relation between the zeros and coefficients of a quadratic polynomial, right? So here even we have to know the general form of a quadratic polynomial or the standard form of a quadratic polynomial, right? Remember that the general form of a quadratic polynomial is ax square plus bx plus c, where a is not equals to 0. This is the standard form or the general form of a quadratic polynomial, right? So now what I do is to know how to show the proof or the relation between zeros and coefficients of a quadratic polynomial, right? So what I do, let here let me take that let alpha and beta are the zeros of ax square plus bx plus c. If alpha and beta are the zeros of ax square plus bx plus c, it means x minus alpha, x minus beta are the factors of what? Ax square plus bx plus c. And in the previous video even we have learned, even if it was multiplied with a certain constant value, the zeros doesn't change, the value of the zeros doesn't change. So here what I do is I just multiply this complete with certain k. Here k is nothing that k is a constant. Let k is a constant, right? In the previous video you can see when we learned the zeros of a quadratic polynomial, even when you multiply a constant value, the value of the zeros of the quadratic polynomial doesn't change. So let's do that now, and let us go on simplifying here. That's let k, if you simplify like x minus alpha of x minus beta, that becomes x square minus x of alpha plus beta plus alpha into beta equals to, right, one second, equals to ax square plus bx plus c. Now we do one thing, k multiply with each and every term here, that is kx square minus x k of alpha plus beta plus k alpha beta equals to ax square plus bx plus c, right? So observe carefully now that if you equate these two equations, already we have an equal sign, right? So now what we do is equating the like terms, right? Equating the like terms here. So here it is kx square and here it is ax square. These are the two like terms. Let me take that kx square is equals to ax square, means equating the like terms. So what happens here? That is as x square eliminate in this both, so that k is equals to a. K is equals to a. So let it be now. Now we see equating the like terms, like your coefficient of x is b here, and here the coefficient of x is minus k of alpha plus beta, right? So minus k of alpha plus beta of x, right, is equals to bx. In this x eliminated, right, and then what we have is minus k of alpha plus beta is equals to b, right? And more, if you go on simplifying this, you get alpha plus beta is equals to b by minus k, right? So that this can be written as minus b by k is nothing but a, so minus b by a. So what you got here is alpha plus beta equals to minus b by a. Alpha plus beta equals to minus b by a. Now we have the last term, that is constant term, right? So that is k alpha beta is equals to c. Alpha beta is nothing but product, right? So alpha beta equals to c by k, means product of the zeros is equals to c by k, where this c by k is nothing that alpha beta is equals to c by a, where we already know that k is equals to a. So with this we have to observe clearly, that is alpha plus beta. What do we got? That means here alpha plus beta, we got alpha plus beta, that is minus b by a, and alpha into beta, that is product, where alpha beta are taken as zeros, right? Means sum of the zeros is minus b by a and product of the zeros is c by a, right? Sum of the zeros is minus b by a, product of the zeros is c by a. So please remember this, and we are going to see that how this will be written clearly, more clearly, right? Now I'm just going to do that. Now let's scroll down slowly, right? So already we have taken a quadratic polynomial, that is ax square plus bx plus c, where a is not equals to 0, right? Now if you look at the sum, here, that is alpha plus beta, we have minus b by a, that is minus b by a minus b is nothing that coefficient of x, right? So that's the reason what we do here is minus coefficient of x by a. A is what? Coefficient of x square. So it is coefficient of x square. Now let me take the product also then. Here what is the product of the zeros? Alpha into beta is the product of the zeros, right? Alpha into beta is the product of the zeros. We got that is c by a. So according to the polynomial which we have taken, that is c is nothing that constant term here. It is a constant term by a is nothing that coefficient of x square. Coefficient of x square, right? So here this is the proof for the relation between the zeros and the coefficients. So here the alpha and beta are the zeros, their sum is nothing that minus b by a is nothing that minus coefficient of x by coefficient of x square, and product of the zeros, that is alpha into beta, is equals to c by a is nothing that constant term by coefficient of x square. Here this is a proof, children. So we will see in the next video. We are going to coming up related problems with the relation between zeros and coefficients. Thank you for listening. If you have any more queries in this, just give us mail at askagaamath@gmail.com. Thank you. Bye bye. See you.